PB Edward. Okay. Everyone saw the whiteboard? Do you hear me clear and loudly? Answer me. Do you see the whiteboard? Yes or no? Do you hear me clear and loudly? Yes or no? Answer by the... You activate the microphone or by the chat. Okay. Ready to start? Ready to pay attention? Ready or no? Come on, answer me. Yes, sir. Yes, sir. Okay. Daniela Rabasa, morning. Okay. Brandon Thomas. It's coming, it's coming. Wow, the student is coming. No, but I don't wait. I don't wait for anyone. I start my lecture right now. Okay. Let's play a game. A game of the surface. Okay, quadric surface. It's a quadric because the exponent is 2, no? Entonces es quadric, quadratic, like a parabola or something, no? A sphere or... Okay, entonces now, yes, sir. Okay. Now, look. First of all, identification. Okay, Leonardo. First of all, okay, guys, I need participation. What is the name of this surface? Good morning. Good morning, no. What is the name of this surface? What is the name of this surface? I need the name. Maria, Jose. Come on, what is the name? Ellipsoid. Very well. How do you know que es ellipsoid? How do you know? What is the clue? Can give me information que es ellipsoid. What is the clue? Can give me information que this is ellipsoid. What is the clue? All terms are positive. Good. And one more detail, the Restrepo. Y everything is square. Because if one is linear, no. It's another thing. Correct? So the clue can give me the information. This is easy because I don't understand, okay, que you don't, we won't be able to identification any surface. You see everything is a square. Everything is positive. Right hand side is no zero, is a number 36. Okay, therefore clear for me at least is ellipsoid. Any question? Do you every student have a question about the identification of the surface or no? Yes or no? No. Okay, look, now I want to take advantage this moment to analyze and detail this. No. Okay. Entonces, I recommend, highly recommend, express this equation en estándar. And standard, you know, the conic section normally right hand side is 1, not 36. So you see, you divide everything by 36. We have x squared over 4, no? Because 36 divided by 9 is 4, no? Plus y squared over 9. Plus c squared equal 36. Is equal 1. Nice. Standard. This is standard. So when the right hand side is 1, must be 1. Must be 1. Entonces es called standard. I suppose you remember very well when you study conic section, no? Entonces I propose you two fantastic ideas. The first fantastic idea is find the intersecting point. Intersecting point. Okay, and this is similar to the 2 dimension. Suppose I assume x equals 0 and y equals 0. Okay, entonces that part disappear. Okay, you are ready, mister? Now we have this equation. C squared equals 36 over 36, sorry, equal 1. And you solving this elementary quadratic equation. Therefore, C is equal plus or minus 6. I suppose you know how you solve it. So you have 2 points. The points are 0, 0, plus or minus 6. So we have 2 points. One positive and one negative on the C-axis. Because the value que you assume que x is 0, y is 0, and c is plus or minus 2 back to solution. Likewise, x equal 0, c equals 0, another variable missing. Because we have y squared over 9 equal 1. Similar, this is the quadratic equation again, and the solution for this quadratic equation is plus or minus 3. And the point is 0, plus or minus 3, 0, because you assume que x is 0, y is 0, and I discover using algebra que y is 2 values. Entonces, finally, no, well, no, the last intercept is when you assume que y is 0, and c is 0. Entonces, es x to the 4th power over 4 equal 1. Now, x to the 2nd power, sorry, equal 4. Entonces, x is equal plus or minus 2. And the famous point is plus or minus 2, 0, and 0. So we discover 6 points on this surface, que es the famous intersecting point. Any questions so far? Do you understand very well this? This is not all. This is the first part. Everyone follow me? Follow me or no? Good. David Restrepo says, yes, professor. Now, I am continue doing more interesting part, que es the traces. Okay, what are the traces? The trace is no, is a plane. The trace is a plane. It's a hypothetical plane. For example, c equals 0. The representation c equals 0 in 3D is a plane. It's a plane, guys, que es parallel to the xy plane. O sea, perpendicular to the c-axis. Exactly, bueno, es the middle, ¿no? It's the middle. O sea, c equals 0 is a plane. It's a plane like that, look. This is my 3-dimension axis. So that plane is c equals 0. As you assume que c is 0, we have x squared over 4 plus y squared over 9, c is 0 equal 1. And this corresponds perfectly to the equation for the one ellipse in 2D. Y I discover que A is, in this ellipse, A is 3. So the major axis lie on the y-axis because the big number is 9. And B is 4. And we analyze exactly the same, but I'll do it quickly, not too fast. Suppose this is the xy axis. XY, not Z. Y, and our ellipse look like that. Like that. Okay. Well, this distance is 3. Because the major axis lie on the y, no? And this distance is 2. This is 2, of course, this is minus 2, and this is minus 3. I promise you see in detail now in Geogebra. Do you understand this idea or no? Confusing, or clear? Okay, trace is a plane. A plane que you assume any, A is 3 and B is 4. Why? Well, I suppose you remember, this is precalculo. Hello. Okay, suppose this is b squared plus y. Okay. Who is A and who is B? Well, A is the big number. Okay, A is A squared is 9, and a 3 gets a square root. And we are talking about this and B2. Of course, B2. Hello, 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 hello. I am crazy, I am crazy. I am crazy, I am crazy. Es obvio que es tú. Es obvio que es tú. Es obvio que es tú. Ajá, entonces, my problem is que I assume que this is too elementary. Entonces I make a mistake. Okay, this is a squared equal 9, and this is b squared equal 4. Therefore, a alone, after you apply a square root both sides, is 3, and this is 2. Super. Okay. Entonces goes with the the reason, Giraldo, que the major axis, the major is the bigger distance, no? This is the major axis lie in the y, and because the big number que es 9 is associated with the y. Okay? Likewise, suppose y is 0. There's another plane, but this plane, suppose that this is the y-axis. This plane look like that. Okay, bueno, si es 0 is here, y equals 0. Entonces now in the original equation, I suppose that y is 0. And my equation stays like x squared over 4. Professor, I can hear you. Why not? Oh, let me see. My microphone is activated. I don't know why you cannot hear me. Everyone hear me or no? I hear. Okay, so you have some problem. This is sometimes happen that situation. So if you don't hear me, okay. Maybe you sign up the application and after signing, and entonces this maybe is fixed. Okay, entonces es c squared over 36 equal 1. This is the equation of the surface. Well, actually it's not surface, it's another elixir, no? It's another elixir. In this case, A is 6 and B is exactly the same too, no? So we have another elixir. This is the axis XC, no? XC. Entonces our conic section look like that. Ooh. This distance is 6. So the major axis lie in the z-axis, and this distance is 2, exactly the same, negative 2. Okay, so when you make it trace it, it's like you know, trace it is when you make it trace it with the surface, you generate like a cross section, and this cross section is flat, it's in 2D. Okay, now the last trace is suppose x0. See, x is 0. So the equation is y squared over 9 plus c squared over 36 equal 1. I discovered that a again is 6 and b in this case 3. And the trace associated with this conic section is, try. This is the y-axis. This is z-axis. Again, it's similar. Look, it's similar. It's another elixir. This the major axis is 6 on z-axis, and this is 3. Conclusion. Professor, I have an issue with the Skype. I hear all the chat noise. Okay, guys, this is the problem of the internet, maybe, or the connection. Okay, one recommendation: when you have problem, you sign up, go out, and when you again click in the link, maybe fix. Maybe I do not guarantee that, but it's there are a lot of issues. We have internet issue. We have computer. I don't know what in what condition you have your computer, right? Okay, so this is the big picture que ilustre que es el ellipsoide. I will watch the recording later. Okay, no problem, Annette. Okay, Annette. Okay. Remember, I posted in YouTube. Try living and join again. Okay, try to living and join again. It's a one possibility. I try to explain. Okay, Annette, try you try. Si you don't, entonces you watching the video in the YouTube. Okay, entonces now, okay, guys, sorry, yeah, no more interruption. Okay, let's go directly to the mathematical. Today we have a lot of topic to cover. Suppose okay, I want to see this picture and GeoGebra. Look at that, boing. Okay, share GeoGebra. Look at that, boom. Do you see GeoGebra? Do you see? Okay, not yet. Oh, not yet. Okay, not yet. Yes, Javier Hernandez. Everyone saw GeoGebra now? Okay. Well, the only thing I did was, I typing the original equation that's given, and not necessarily standard. Now I plot the different intersecting point. Look, 6 and -6. Boom. Do you see the point? AB? Do you see CD? Que es 3 and -3 on the y axis, que es the green. The green is the y, the red is the x, and the blue is the z. And 2 and -2. Boom. This is the 6 intersect que we found before. What about traced? The traced is the conic section. When you, for example, look at that. The trace is, pay attention, you plot the point z equals 0. Boom. Z equals 0 represent, look at that. Is the xy plane, z equals 0. And the curve, que es the intersection, is this. Do you see that? It's the ellipse. Exactly the ellipse that we discussing. Okay, no, like that. Okay, remember the ellipse is the major axis 3 and the minor axis 2. This is the x axis, is the red one, and the blue axis is the y. And the C in this moment is missing because I rotate the figure. Okay, so now suppose another plane. So suppose another plane, x0, boom. It's the green plane, x0. It's a traced. Now the traced in this case is like that, boom. It's ellipse. Look at that, the ellipse. The ellipse, of course, this ellipse, the major axis is 6 and the minor axis is 3 in the x. And finally, another plane, y0, boom. Yellow color. Now the trace in this direction is this, bam. Then we have 3 ellipses. That is the reason que es ellipsoid. Everything is clear or confusing? Everything is clear or confusing? Come on, guy, answer me. Everything is clear or no? Understand. Okay, you understand. Okay, now. Let's move on to the whiteboard again. Clear. It's my intention. My intention is everything is clear. Okay, we come back to the whiteboard. Everyone saw the whiteboard in this moment? Yes. Okay. I bring another example. Suppose this example is z. Oh, well, no. Well, okay. C is equal x squared plus 4y squared minus 4. Identification this guy. What kind? What is the name of this surface? You can see, okay, for example, we have 2 squared. No, so okay. The collection of the variable x, y, and z is present in this equation. Nobody is missing. See, nobody is missing, it's no cylinder, a surface. Now 2 squared and 1 linear. What is that? What is the name of this guy? Name. Only identification. Name. What is the name? Only identification. Elliptical paraboloid. Very well. Elliptical paraboloid. Elliptical paraboloid. Very well. Okay, so let's move on to the intersecting. Intersecting is, suppose, x0 and y0. Si x es 0 and y es 0, es obvio que z es equal to -4. And the point is the point 0, 0, -4. Entonces in this case we have only one intersecting, not two. Because the problem is that this surface is open in the positive direction, no? Entonces we have only one intersect. Okay. Suppose now x0 again and c0. Entonces now we have x0, c0. The equation that we have in my hand is 4y squared minus 4 equals 0, no? And you solve this equation. It's super easy. You, for example, 4y squared equals 4 divided by 4 both sides, y squared equals 1. Therefore, the solution of this equation is y equals plus or minus 1. And so we have two points. We have to intersect to get the point 0, plus or minus 1, 0. To intersect. Okay, I like that. And finally, y0 doesn't matter the order, no? And c0. Entonces, when this situation happens, bueno, the equation that we have in my hand is x squared minus 4 equals 0, no? This is 0, this is 0, Es obvio que x squared equals 4. Es obvio que the solution is x equal plus or minus 2, no? So we have 2 points again, it's plus or minus 2, 0, 0. Super. I have, in this case, no 6 points. We have 5. 1, 2, 3, 4, and 5. Because C contains only one. Only one. Okay, now let's go move on to the trace. The trace is C equals 0. It's a plane. See, C is equal to 0. My equation is so far x squared plus 4y minus 4 equal to 0. When you suppose que C is 0. Therefore, x squared plus 4y squared equals 4. If you want to express in standard, you divide by 4. Remember, right hand side must be 1. We have x squared over 4 plus y squared over 1, invisible. If you want, you put a 1, but I don't like, equal 1. It's elixir. It's obvious que es elixir. That is the reason que the name of this surface is elliptical. So we have, the name contains the noun and adjective. The noun is the most important. They consider it as paraboloid, it's a parabola. However, in one trace behave like an elixir. This is the case. This elixir, let me try to do my best by hand. X and Y. The major axis is, o sea, A is 2 and B is 1. Okay, you suppose the big number 4 and square root 4 is 2. Entonces our elixir look like that. Okay, this is 2 minus 2, this is 1, and this is negative 1. This is a trace, que es the, you know, it's like a floor plan. When you look in the elliptical paraboloid, you're looking from the top, and your eyes point from the bottom. Okay, this is the elliptical paraboloid. Okay, I like that. Now, suppose another trace, suppose x equals 0. Entonces my equation is z is equal 4y squared minus 4. Entonces your identification que this is a parabola. Now when the one guy is linear, and when the other guy is quadratic, it's a parabola. By the way, this parabola open up. How do you know they open up? because the term can contain y squared is positive. And the z-intercept, suppose in my mind, okay, this is the y-axis, and this is the z-axis. X-axis is missing because I assume it's 0, and this parabola open up from one specific point gets -4, open up in that direction. Ese parabola. That is the reason que es paraboloide. Elliptical, look, paraboloid. Now for y0, for y0 is, well, my equation is reduced like that. X squared minus 4 equals z. Entonces we have another parabola, no? And we have another parabola, okay, this parabola again open up because the quadratic term is x squared, the coefficient is positive, no? But the intersecting again is -4. So my graph of this parabola, this is the x-axis, this is the z-axis. Ese parabola, que again is -4, open up. I suppose that this is a little bit wider parabola because the coefficient is 4, so P is 1. I don't know if you remember the equation for the parabola. The equation for the parabola is in 2D, when you study 2D, is, for example, y is equal to 4p x squared, no? And the coefficient for p, give me the information in what direction open the parabola. Now, p is 1, but p here is 1/4. This parabola is narrow, this parabola is wider. Okay, super. Okay, so I have whole information to see. Let me try to find in Geogebra. This is the complicated part for me now. Okay, here, okay. I try to open new one. Trace elliptical paraboloid. Okay. Bang. Okay. Let me try to share the screen to Geogebra. Okay, switching to this. Do you see? Wow, this is our famous elliptical paraboloid. This is our famous. I plot directly to save time. The most important point, the 5 point, okay, 4 point on the XY plane, and 1 point on the Z-axis, que es -4. Do you see that? And the surface, suppose this trace, boom. Okay, suppose it's this invisible. No paraboloid anymore. Look, I am switching. This is the elliptical paraboloid, elliptical. And this is parabola, no? Parabola. Look at the parabola. This is parabola is narrow. And the other parabola, here, is wider. Look at that. Okay, so the combination, two parabola, open up. And one is elliptical paraboloid. Bang! Double bang. Okay. Everyone understand very well or no? No? So confusing? Oh, clear. Pretty cool. Super. Okay, we continue with the game. The game. Okay, no. Okay, whiteboard. Switching to whiteboard. Boom. Okay, erase. New problem. We continue the game. I put equation and you identification. You only try to determine the name of this new lady. Suppose c square minus 9x squared minus 4y squared equal 0. Identification of this guy. identification of this guy. What is the name? First name, last name. Hyperbolic to chi, no. I agree, totally disagree. Here I do, look, the clue. I suppose que I put here 10. I agree with you. So when the right hand side is completely arbitrary number, I agree with you que es hyperbolic to chi. But in this case, 0. And this indicates me immediately that we are talking about con, double con. A con, double con, when the right hand side is 0. Okay, this is important details. Important detail cuando es 0. Si es a number que no 0, different to 0, entonces es hyperbolic to chi. I agree with you. Okay, entonces ese con. Suppose que I want to find the intercept. Look, x0 and y0. You plug in here, it's obvious que C es 0. This implies que C es 0. Entonces we have only one, que es the point 0,0,0, intersect. Because I suppose que this con is along. What axis is along? So what is the con? What is the con? Con, in what direction is the double con? X, Y, and Z, no? Remember, in the con, we have two same signs. Now you analyze the signs. So when you have the same sign, the other sign gets different. So if you, to see much better, you multiply the whole thing by -1, well, if you organize in alphabetic order, so you put 9x squared plus 4y squared minus c squared equals 0. Oh, more clearly for me. I found the intercept that is 0,0,0. Is here. Bang. And this double con open along the CX. So it's along CX. Why? How do you know? Because it's the guy can have different side. That the double con look like that. Boom, 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 boom. Double con. Okay, double con. This surface look like that. Okay. Entonces now, normally the trace it that we are doing is doing C equals 0, but no, this is not good because C equals 0 is the origin here, que es the only point. So suppose that you make a trace using that plane. You get the only number is 0. Entonces 0 is not good. I erase 0. You say I select no necessary 0 always the trace. You select arbitrary number because it's the same plane in the same direction, and you cross a little bit our helix. Okay, I assume que C is 6. Si es 6, entonces maybe we have a plane like that. Look, this is C equals 6. And what do you expect? You expect helix. Okay, let's try. Entonces 36. Well, no. Let me use the other equation que es easier. This equation is nice. Entonces 9x squared plus 4y squared minus 36, because I assume que C is a constant, equals 6 equal to 0. The equation is 9x squared plus 4y squared equal 36, expressed in standard, divided by 36. Remember, right hand side in the cone should be 1. So this is x squared over 4 plus y squared over 9 equal 1. Okay, entonces I see clear que A es 3 and B is 2. And this look like elixir. This is the plane xy, no? Xy, because C is parallel to xy. Sorry. C is parallel to this. You don't see in this moment when you make it trace, no? And also this is 3. 3, 3, 3, 3, 3. This elixir look like that. This point is 3, minus 3. This is 2, minus 2. How do you choose the right trace? Well, using your imagination. Using your imagination. Using your imagination. So there are no rules, there are no recipe. Okay, using your imagination. You suppose 0. And when you plug in 0, you get the point. Entonces you assume. You have ese combination, intuition, recognize que surface que we are working is a cone. And you suppose in your brain, you imagination a little bit cone. Entonces now a cone. So I need to take another. This is example que illustrate que not always the trace is when it's 0. Maybe you select another point. I select 6 because I want the number is nice number, 4 and 3, 2, A, 3, B is 2, but no, you select another crazy, suppose A. Entonces maybe when you have A, you have different number. But also no nice number, maybe it's irrational number, but it works perfectly. Okay? Matching. Okay, it's perfectly understandable. Okay, let me move. Okay, in this case, to save time, I know que es con, I know que es elliptical con, no circular con. Now I move it to the Geogebra to see that. Okay, let me try, open. This is the gone. Okay. I need to wait to saving and loading a gone. Look at that. Do you see? No, you don't. You don't. Boom. Do you see? Yes. Okay, it's a con. Double con. Look at the famous plane I am using to make it trace. There's a plane C equals 6. Look at that. And you see que the curve in 2D is Alejandro Richter. Okay, look at that. Let me remove the plane, no plane anymore, and no cone anymore. This is my elixir. Okay, the elixir is XY. Let me rotate like that, XY. And the intercept is 2, and the intercept is 3. Good. Nice. Do you see? Clear or confusing? A con. Double con. Double con. Okay. One more example. Guys, do you feel okay? Or you feel confusing? I suppose you feel always confusing. This is calculus 3. Calculus 3 is horrible. I told you. However, we try to do our best, no? Okay, let me try to go back to the whiteboard. Whiteboard now. Okay, another problem, and you help me. Okay, this is example. We are doing number 1, number 2, number 3. This is 4, no? Example 4. This is example 4. Suppose 9 x squared plus 9 z squared minus 4 y squared equals 36. Identification, this connect section. Identification, this connect section. Well, see you done identification, this connect section. Okay, I propose you express in standard and organize in alphabetic order. So you divide everything by 36. Because remember, in the standard, I need right hand side 1, and there are no reason to do not respect the alphabetic order. So this is x squared over 4 minus hyperbolic 1 sheet. Yes, you are right, Gerardo. Gerardo, identification is hyperboloid 1 sheet. Well, entonces I put a y square over 9, ¿no? Plus c square over 4, no, over 9, ¿no? Over 9, ¿no? Over 9. A ver. No, over 9, yeah. Okay, hello. What the hell? This is 4. This is 9. This is now 9. This is 4, right? Okay, this is 4. What the hell? This is 4. This is 4. This is 9 and this is 1. Okay, let me fix it. I did wrong in my paper, but I fix it. Okay, 4 and 9. Okay, no problem. I try to fix that. Okay, entonces U identification, que es hyperbolic one sheet, right? Because what is the glue? What is the glue? Identification. Remember, this is a skill we have in our brain, que we know some feature about one object, and you identification, look at this. Okay, number 1, stay present all the collection of the verb X, Y, and Z. Stay present que everything is a square, no linear. Si es línea es paraboloide. Si es square, no paraboloide. And one guy es negative. Si one guy is negative, es hyperboloide one sheet. Along what? Along what axis? Along what axis? Along the y-axis. Very well. Along the y-axis. Because it's the only guy is negative. This is the glue. This is negative. Give me information. So you have two negative, one es another figure. Okay? So one negative is hyperboloid one sheet. I repeat again. We have three variables, X, Y, and Z. Everything is a square. And one negative, hyperboloid one sheet. End the story. Okay? Now let's compute the intersect. Suppose x0 and y0. So we have c squared over 9 equal 1. Equal 1. Therefore, it's obvious que c is equal plus or minus 3, no? And we have point. Okay, here's the point. I make a mistake here. Let me fix it in my paper. This is 3. The point are 0, 0, 0, 0, 0, 0, 0, 0, plus or minus 3. Super. I fix it in my paper. Okay, now suppose another intersect is x0, z0. Okay, entonces my equation it look like that, minus y squared over 9 equal 1. So something weird happened here. Because actually my equation look like that, minus y squared equal 9. Y squared is equal to minus 9. When you apply square root both sides, it's obvious que it's imaginary. It's plus or minus 3i. And when this situation happens, you know, in algebra, when you try to find something in algebra, and the answer is complex or imaginary, it's because do not exist. So we have no intersect in the y-axis. Okay, because I declare x0, z0, so we are finding, or try to finding, but it's impossible, the y-intercept. Okay, now finally, this is y0, z0. My equation is reduced like that. Equal 1, this is obvious plus or minus 2, no? And the point R plus or minus 2, 0, 0. Okay, so we determine only 4 intersect in the hyperboloid of the one sheet. Okay. Now let's go move on to the traces. The traces I suppose assume y0. Okay, the order is not important. I assume y0. Y0 is x squared over 4 plus c squared over 4 equal 1. Es elixir, no, it's a circle because A and B is the same. Therefore, we can express it like that. Sorry, we can express it like that. X squared plus C squared equal 4. It's a circle. And by the way, the center of this circle is the point 0,0 and the radius is 2. So the representation for this is the x0. I assume always x is in the horizontal axis, and depending the other variable, I put z or y in the vertical axis. This is one convention, but not exactly the same. This is a circle. This is a circle. This is a circle like that. Oh, bang. It's 9 or 4. I mean, I'm making a mistake maybe, no? It's 9 meters because 36 divided by 4 is 9, no? This 9 comes from 36 divided by 4. 36 divided by 9 is 4. 36 divided by 9 is 4. Entonces es, wait. The same mistake, ¿no? ¿O no? A ver. What's the problem? Es 4. So si you delete mentally y0, boo. Yeah, es 9. Yes, entonces no circle. Carajo. A ver. A ver, es 4. You're right. I have an advanced student, good student. Actually, it's no circle. It's elixir again. Okay, let me erase everything. Okay, because my paper I make a mistake. Entonces 4 es 9. Yeah. Entonces es obvio que ese elixir A es 3 and B is 2. And the major axis lie, this is XC. The major axis lie in the CX. So my elixir look like that. No circle, it's elixir. This is 3. This is negative 3. This is 2. And this is 2, minus 2. Wow, I make a mistake. Okay, let me fix it in the paper. Wow. 3, I am a human guy. You know. Okay, it's a 9 here. Entonces es elixir, no circle. Okay, super. Let's continue with the traces. No problema. Everyone follow me. Okay, suppose I have some problem in the other traces. But let's try to do our best. X equals 0. Wait, I think it's 4. What's the problem? Okay, this is 9. This is 4. This is 4. Si I assume que y is 0, it's different. No es 4, it's 9. It's 9. 36 divided by 4 is 9, no? Everyone is agree or disagree? We are doing well now or no? Okay, suppose x equals 0. X equals 0. 9 over 30. Oh, but this is the original, no? Okay, no. This is the original. This is the original, no? The original equation I write was 9x squared plus 4y squared plus 9c squared equals 36. This is the original, no? When you divide by 36, oh yeah, okay, coño, carajo. Okay, this is x squared over 4 minus y squared over 9, yes, plus c squared over 4 equal 1. Carajo, it's okay. Entonces I am doing well. I am confusing by myself. No, carajo. Okay, entonces we are doing well here. I always check in the Geogebra. Entonces I suppose que Geogebra you see perfectly. Ajá, entonces si you suppose que y es 0, this part disappears, it's gone. Ajá, my equation is reduced like that. It's x squared over 4 plus c squared over 4 equal 1. Now x squared plus c squared equal 4. It's a circle. It's obvious it's a circle. Circle with the center is located at the point 0, 0 and the radius is 2. Okay. Well, no, actually it's no plus or minus. So the interest, you're right. Another clue here to say, Professor, the intercept and the y is plus or minus 2. So my circle look like that. This is x, this is y, this is z, sorry, and this is a circle like that. Boom. And this is 2, and this is 2, and minus 2, sorry, this is 2, and this is minus 2. Okay. Not bad. You know, the mathematics is horrible. One stupid mistake. Mistake you copy wrong. No mistake you don't know. You copy wrong. However, this continue with the mistake, no? Okay, let's okay, you help me, guy. Remember, this is, let me copy the original equation. This y here and 9 here. Is correct? This equation is correct? And this is 4. Okay. Again, I fix it in my paper. Carajo. Okay. Now assume x0. Assume x0. Assume x equals 0. Okay, see x is 0, this part disappears. And we have minus y squared over 9 plus c squared over 4 equal 1. Now identification in 2D. What conic section it is? It's a hyperbola. It's a hyperbola. Let me write an elegant way. Normally, hyperbola, you put the positive first. Not exactly, do not respect the alphabetic order, no. You put the negative in the second place. And equal 1. So you determine que A, que by the way, A in the hyperbola always is the term is positive, is 2. And B is 3. But the most important is not who is A, who is B. So you know what kind of hyperbola. Okay. Hyperbola, remember, a little bit different. The most important in the hyperbola is, this is the y-axis, this is the z-axis, is in what is the transversal axis. This is the name, transversal axis. The transversal axis is in the positive direction, que es C. Entonces, our hyperbola look like that. Bam. Why? Because C is positive. Si C is negative, entonces y es positive, entonces es in the opposite. So the transversal axis of the hyperbola lie on the z-axis. Okay, that is a reason que the name of this is a hyperboloid one chip, because we have it formed by different hyperbola. Let me see what happened in y0. Y equals 0. Y equals 0. We come back to the original equation to don't make a mistake. Now y is 0. Entonces es x squared over 4. X squared over 4 minus y squared over 9. No? Let me see. Over 9. Yeah, over 9. This is 9 now. Equal 1. No? Okay, now this is also hyperbola. So it's hyperbola. The trace, que es the two-dimensional figure for the surface. When I investigate, I see that this surface is formed by a circle, okay, and two hyperbola. Wait, but the term is 0. What is 0? Y is 0. Okay. My equation is x squared over 4 minus y squared over 9 plus c squared over 4, and we assume now that y is 0, no? Y is 0. Look at that. We are doing this. Y is 0. This trace. Entonces this part is 0. Entonces 4. F4 here, right? F4. Again, the same stupid mistake. F4. Okay. Okay. Thank you. But this is also hyperbola, right? But the problem is AS2 and BS2. So our hyperbola, let me try to do here in this corner. This is x-axis and this is y-axis. It's a hyperbola also, and the hyperbola, the transversal axis lie in the x-axis. This is our transversal axis. Therefore, our hyperbola look like that. And this number is 2, and this number is -2. By the way, this number is, let me see, in z-axis here, is 2. It's also 2 and -2. This gives me some information about our famous hyperboloid one chip. Hyperboloid one chip. Let me try to find in Geogebra this figure. Bang. Okay. Open. Hyperboloid one chip. Open. Okay, open. I open different folder. I want to send you to use this. Good, very good. Okay, now I need to share screen. Okay, switching to bang, 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 bang. This is our famous. Look like double trumpet. Look in the middle, it's empty. Okay, that's a reason we have no intercept. Now, do you see or no? Our famous hyperboloid one chip. Do you see or no? Answer me. Yes. Okay, look. Suppose the trace it, que is the most important, no? One trace is this, bang. Look, it's a circle. Let me delete the hyperboloid one chip, and this is the famous circle that we working before. Okay, the center is located in the origin 0,0 and the radius 2 in any direction. Okay, good. Okay, now we come back to this. Another trace is bang. This is the hyperbola. Look at that. Wait a second. Let me delete momentarily. Okay. This is the I suppose que, okay, I suppose when the x is 0, no? It's x0, entonces the hyperbola open in the z direction, so that the axis, the transversal axis lie in the z direction, and the intercept stay the same, 2 and -2, no? Wow, beautiful. Look at that, the trace. And the last trace is also another hyperbola, bang. But this hyperbola is in the other direction, okay? And this hyperbola, let me delete momentaneously and try to find the x. Let me rotate here, xy. The another hyperbola, the axis of transversal is lie on the x-axis, and the intersect is the same 2 and -2. No? Wow, amazing! We are the best in Miami-Dade College. Yes or no? Okay, look, hyperbola, another hyperbola, and circle. This is the hyperboloid one chip. Any question? Any question? No question. Ooh. Okay, I enjoy teaching this student. He understand very well everything. Your only problem is that you don't start doing the homework yet. Okay, this is a big problem. And you believe that the last day we can do that, because this problem is too easy, and this problem is not too easy. It's too hard, and you spend a lot of time doing that problem. Number 5 example 5. Example 5. Example 5. Example 5 is minus y squared plus x squared plus 9c squared equal no. Let me try to do something to confuse you. Plus 9 equals 0. Suppose in the test I put something like that. And I ask you only identification. What conversation? What conversation? No, sorry. What surface we have in this moment? What surface we have in this moment? What surface we have in this moment? No idea, right? No idea. Totally lost. Okay, we have the collection X, Y, Z. Okay, no cylinder. We have one negative. But no good. Because on right hand side 0. Giraldo, very well. Because you have to organize. Recommendation. Organize in alphabetic order, number 1. Number 2, you put a coefficient without a variable to the right hand side. Always. So I copy like that. X squared alphabetic order minus y squared plus 9c squared equal negative 9. Wow, what the hell is that? Professor, you never explain me when you have negative number in the right hand side. Okay, sorry. You divide by negative 9 everything, because I know the professor just explained me that in the standard form, que es the form que I need to express it, right hand side must be 1. Entonces es x minus x squared over 9 plus y squared over 9 positive, and minus 9 divided by 9 is 1, but it's negative 1 actually. C squared equal 1. Nice. This is the, in this moment I am ready to think what is the classification for this surface. We have the collection X, Y, and Z. Everything is a square, but 2 negative and 1 positive. Okay, so this is hyperboloid to chip. And my question is along what axis? Along what axis is this is hyperboloid to chip? By the way, hyperboloid to chip look like a 2 paraboloid, but actually it's no paraboloid, it's hyperboloid. Okay, this is the Y, this is the X, this is the Z. I have a roughly sketch. And hyperboloid two sheet look like a 2 like that. It's along the y-axis. How do you know? Because it's the only positive, only different sign. 2 negative is 2 chip. See, 1 negative, 1 chip. And the different is always the information for along y-axis. Okay? Okay, let me try the intersecting and traces to investigate the surface. More detail. Suppose x equals 0 and y equals 0. Entonces we have the equation que es minus c squared equal 1. It's obvious that when you multiply by negative 1 and you try to find square root 1 of c squared negative 1, and you try to find square root is imaginary, entonces that is the reason that we have no this intersect. So c equal non c. So no, this figure never intersect the z-axis. No. Okay. Now let me see x0 and z0. Well, entonces is bueno, see, this is 0, this is 0, is y squared over 9 equal 1. Okay, nice. It's equivalent to say y squared equal 9, therefore y is equal plus or minus 3. Okay, we have In the y-axis, yes, we have. We have two famous points, get 0, comma, plus or minus 3, comma 0. Let me try now in the next intercept, que is on the x-axis, no? To declare x-axis y0 and c0. When the situation happen, similar situation happen, x squared over 9 equal 1, no. So we have only intercept, this figure, this surface have only intercept on the y-axis. In the z-axis, no. In the x-axis, no. No. Let me try to do make traces. As usually, we start C0. That is not important. CC is 0 in the original equation. My equation is minus x squared over 9 plus y squared over 9 equal 1, no? Okay, so this is, I copy in the elegant way, you know. The elegant way is y squared over 9 minus x squared over 9 equal 1. It's a hyperbola. Hyperbola whose the, well, A and B is 3, both. It's a coincidence, but it's not important. It's important for the asymptote, but actually our hyperbola is xy, and the transversal axis is on the y-axis. Our hyperbola look like that. And by the way, this point is 3 and minus 3. Okay, the intercept we found before. Look. Oh. Okay, no, good. Let me try now y0. Let me try now y0. But y0 is not good. No, because I discovered that we have no intercept. So now I propose you determine another trace case not in 0. Determine another trace case maybe 1 point. So this is the challenge. What is the good selection? Well, they are arbitrary number. I select 3 radical 3. Do you see why after 3 radical 3? So my equation is, let me try. Okay, equation, the original equation here. Okay. You replace 3 radical 3 here. So my equation is minus x squared over 9 plus, well, square this guy is obvious que es 27, no? Y 27 divided by 9 is 3. That is the reason I select this weird number, no? Minus c squared equal 1. Now, okay, I organize this as minus x squared over 9 minus c squared over 1 equal 1 minus 3, que es negative 2. Pero I know que in the conic section right hand side must be 1. Okay, entonces I divide whole thing. I divide the whole thing by negative 2, negative 2, negative 2. It's obvious that we have x squared over 18, no? 18 here, 18, positive. Plus c squared over 2 equal 1. Entonces this is obvious que es elixir. Elixir de A, que es the major axis, es 18, ¿no? Es square root 18, ¿no? Square root 18, square root 18 es 9 times 2 es 3 radical 2, I suppose. And B is radical 2. It's a weird number, but it's okay. But your identification, this the most important is no the position, no, es your identification gets elixir. And the major axis lie in the x-axis. This is X, this is Z. Entonces our elixir look like that. Bam. Bam. And this segment here is 3 radical 2. And this segment is radical 2 and negative radical 2. Okay? This is elixir. Now, finally, the other trace is suppose x equals something. X equals something. I assume the same value, 3 radical 3. Guys, this is okay. I want to show you. No, don't frustrate. What number are you using here? Arbitrary number. What is the reason I don't use a 0? Because I know that this hyperboloid is too cheap. Have a hollow in the middle. It's two bell. Look like 2 bell. Look, 2 bell. So see, you make it trace it in one plane here. So you make it trace it in one plane here. You have nothing. So you need to move this plane totally arbitrary. Suppose I move like that. Entonces, in this moment, we have a elixir, right? Using your common sense and imagination. Remember, you want to become engineer or scientist, right? So similar, I am doing fast, guys. Plugging in x in the original equation. The original equation is this. It's minus. Oh, well, let me see again. Let me copy again the original equation. The original equation, I forgot, is minus x squared over 9. Okay, plus y squared over 9 minus c squared over 1 equal 1. This is my original equation. This one, I copy that. Okay, now I assume the trace it. Okay, it's x equal 3 radical 3. So this is 27. It's a minus 3 here. Plus y squared over 9 minus c squared equal 1. Okay, let me try. Y squared over 9 minus c squared equal 1 plus 3 que 4 divided by 4 because I want to express it in standard. Entonces es y squared over 36 minus z squared over 4 equal 1. Okay, more clear now for me. This is hyperbola also, no? And this hyperbola, A is 6 and B is 2. Okay, this is my famous YZ axis. Y I understand that the hyperbola, the transversal axis, lie on the y-axis, like that. This is my hyperbola. Okay, this is my hyperbola. Okay, let's see. And by the way, this number is 6, no? This number is 6. 6 and negative 6. Okay. Let me try to go to Geogebra to understand much better this. Okay. Concentration, Geogebra. Okay, I try to find another problem. Open. To cheat. Save that. Okay, I got it. Now let me share screen now. Share screen to Geogebra. Boom. Do you see the Geogebra? Do you see? No? Yes or no? Guy, are you tired? Come on. I see. Okay. Do you see the hyperboloid to sheet, right? Hyperboloid to sheet. Okay. The only intersecting point that we found was this. and 3 and negative 3. Okay. However, the trace is, look, one trace is this. Boom. Let me delete the hyperbola. Okay, x, y. Here, over there. Okay, super. Another trace is this. Boom. Wow, what the hell? Let me try to see in 3D. Oh, it's elixir. Look. I create one plane. Okay, this is my surface. But I don't want to complicate your life. Let me delete the hyperbola. Okay, I make a trace. Okay, look. You can. Okay, in Geogebra, for example, if you define one plane, okay, this plane is the plane y equals something, and you put h, I put h here. H is a slider, I suppose, no? Or h is a value. I declare h like radical 27. Okay. However, in another direction, let me see another direction, get the hyperbola. Look. I suppose, and h, I delete h. Wow. Oh no, let me see, man. No, doesn't work. Okay, sorry. Okay, another is, look. Another is the plane x equal h. Let me delete that. Okay, this is hyperbola also, right? Hyperbola also. This is the y. All right, let me rotate. YZ. Okay, YZ. Maybe it's different because I'm using different value here, but it's okay. You see the hyperbola to chip is a combination of hyperbola when you make a trace and one elixir. Everything is clear or confused? How you can tell the last one was hyperbola and another is elixir one? Oh, okay, hyperbola. Okay, I suppose you remember this is the equation for the elixir: x squared over a squared plus y squared over b squared equal 1. It's elixir, right? I don't know if it's your question. However, when you have x squared over a squared minus y squared over b squared equal 1, it's hyperbola. Can you share the whiteboard? Sorry. It's complicated for me share in the moment because in my mind I focus here in the mathematics. I forgot to share. Okay, the thing I try to explain. I suppose that you know very well. Okay, elixir is positive and hyperbola is negative, no? The sign is different. Yeah. Okay. Hello, guys. Hello. This is a precalculo, no? Precalculo class, conic section. I explained very well. And the fall. Okay. No more. I am boring to this. I am boring. No more. I have another example. Pero no, it's enough. Entonces, I want to start a new section que es super important and super hard. New section. Okay. In the email que I sent today, I will send the video of this class, this lecture, plus the different link connected with the Geogebra. We have this example and one more. Okay, no, we have no time to do this. And you open, and feel free to do everything. You do your modification, you create using your imagination to do this. Okay. Now let's come back to the last section. The last section is very hard. Not hard, but it's too long, and and the problem is complicated. But complicated in calculus part. So differentiation, exactly. It's a vector value function. Vector value function. Okay. Vector value function. Vector value function. Okay. Are you familiar in Collet algebra with the function? Function we can interpretation like a black box in which you have one input I call x normally, and we have one output que es y. And by the way, the mathematical expression for the function f of x is equal to this. This is the classical idea for the Collet algebra, no? Now we introduce today a new idea that is vector value function. What is that? It's similar. It's similar. It's similar. We have one input again, que es scalar. Normally it's called no x, no t. T because this is used in physics view, and t represents the time. Pero no necessarily t is a time, it's a parameter. Okay? And we have vector value function. And the output is a vector in 3D or in 2D, depending on the problem, no? And the vector is x to t, a function, comma, y to t, comma, c of t. Okay, entonces the vector value function offer, the answer que offer is a vector en 3D o en 2D, depende, ¿no? Si es 2D, this part is missing, ¿no? Pero it's okay, depending on the problem you can see. It's a multivariable calculus. It's the first example that you see. In the next chapter, in the chapter 2, you see more options. But in this case, it's called a vector value function because we have only one independent variable, real. The t belongs to the real number. Not necessarily all real number. Depends. It's one interval, from A to B. And generate different vectors. This. So what is interpretation? What is the first interpretation of this? Guys, pay attention, focus and concentration. This is very, very conceptual, hard problem. This is x, y, z. Therefore, when you using this vector value function, we can generate a curve in 3D. So any point on the curve, suppose this point, P, we can associate one vector like that, the position vector. And the position vector is this position vector que contain the component x, y, and z. But in this case, x, y, and z are a function of t. And so when the t vary, the position of p change like that. Bang, 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 bang. This is the idea. You say, Professor, what is the reason that they complicate the idea? Well, no, complicate the idea because the fact to convert it as a vector allow us to fantastic application for the calculus. Because we cannot derivate a point, but we can derivate the vector. Let me how. So the position vector, normally, I don't know, the book call it R. R is like a displacement position vector. To any time is the vector associated with the three functions. I suppose xt, yt, and ct. Entonces to discover, this is the one thing that you never see before in your life. It's particular specific property for the curve. So we study in any complicated curve in the three-dimensional space. We study different points, different parameters using calculus. Okay, using calculus. It's important to understand. So let me repeat again the idea. Look. This is a vector value function. The domain of the vector value function is a real number, only one number. Well, it's a variable, no, but it's a number. And the domain, the range domain is one number. It's a vector in 3D or in 2D, depending on everything. Now, it's important to understand one idea. Look, a curve represents one dimension object because it's a curve, exactly like a line. When we study the line is the one-dimension object. But this one-dimension object may be line, que es a particular case of the curve, or the curve in general, living in the three-dimension context. Three-dimension context. Okay, the three-dimension context is R3. Okay, so the representation, the algebraic representation is one vector value function. Now the domain is one dimension, and this represents one line or one curve, but this one curve is traveled in the three-dimension context. That is the reason that we have three components, no? 1, 2, and 3. These three represent the dimension for the context, the environment, living this curve. This is not new for you, because you see the equation of the line and parametric, right? And the equation of the line and parametric, we have three components, x, y, and z. But in this case, a line is a linear function. So this represents three. But now we study now no linear, sino non-linear function. And this represents a curve. Make sense? Make sense? You understand this idea? A curve. So the way to represent any curve in 3D space is using vector value function. But we have more because we can apply calculus. And remember, calculus is super important because I want to find the change, the rate of change, derivative, right? Derivative is rate of change, or antiderivative. We apply exactly the operation that we studied in calculus 1 and now in calculus 3, but separate in three components. For example, I compute the derivative of this vector, prime, with respect to time. So you derive component by component, x prime, comma, y prime, comma, z prime. And by the way, this vector represents the velocity in physics. So the derivative of displacement is the velocity. Okay? And the second derivative of the displacement is the acceleration. This is velocity. Let me copy the name. This is now we interpret it like a displacement. Okay, it gets the point, no? On the curve. Velocity and second derivative is acceleration. This is not new for you. You're studying physics, right? Or in some application for the calculus. And the motion problem, no? Acceleration. Okay, acceleration is the second derivative. And the third derivative, you never see maybe, but we're using in one moment. Okay, the third derivative, y3 prime, c triplet prime. It's called jerk. The name is jerk. What is the interpretation of jerk? It's over acceleration. But don't worry for this. It's not too important, but in one moment we need to use the third derivative, right? And also the absolute value. So exactly the same. It's a vector. We are working with the vector. So we are working with the vector. So any vector we can compute the magnitude, right? The magnitude, and the magnitude of the vector is square root. Square root what? Square root the first component square plus the second component square plus the third component square. And by the way, this function is a scalar, no vectorial anymore, and this is the speed. It's the speed. It's the famous speed you're working. And this is a scalar, right? This is the vector, and this is a scalar. No vector anymore. It's a function. No number. It's a function as a function of t. Pero it's a scalar. It's a speed. Okay? Now, one more. Well. So you find, for example, the integral from a to b of the magnitude of the velocity, que es speed dt. Okay, this give me the r length. So we have a curve. I need the function velocity. I need the function speed when you find the actual value. Entonces I need to find the r length. O sea, let me call capital L. R length is that distance when you travel on the curve. Okay, you take the actual value. This is not new for you. Maybe in calculus 2, the professor explained different formula, but it's the same stupid thing. Look, square root is dx dt square plus dy dt square plus dz dt square. Now maybe this formula is familiar for you. dt differential. Don't forget dt. This is the formula that we studied in calculus 2, the r length formula. Do you remember this or no? No, remember. Yes, remember. You remember very well. And that's it. No. Sometimes we are doing back because we're using calculus. In calculus, you find the derivative or the antiderivative. So, for example, so you have the function of the acceleration. Suppose que I have acceleration function, que es the second derivative, no? Acceleration function, and you perform the antiderivative of this, like a vector. So suppose, guys, here we have a vector, x, y, z. And the antiderivative of the vector is the antiderivative one by one function separately, no? It's easy, it's elementary, right? And suppose that you evaluate in between 0 and t is a variable. Entonces si this is t, entonces this is, suppose que es another variable, normally u, the antiderivative. Entonces give me the velocity. Give me the velocity vector. Si you integrate one by one separately, component by component, you get the velocity plus c, the arbitrary constant. When you find the antiderivative, always you put the 0. But in this case, it's no number, it's a vector also. And by the way, it's the initial vector because you evaluate 0. This is a vector also. Look, 3 components, bang, bang, bang. But this component is a number in this case. In this case, no. In this case, this component is a function. I promise you see example of this. This is only theoretical introduction, right? Likewise, if you have the velocity function, I declare u variable, not t, because when you define, when you define it integral, and you one limit is upper limit is a variable. So you put t is okay, but you know. The book prefer using another variable, u or tau, whatever you want. Entonces this is displacement function. Again, it's a vector value function, 3 components depending on the time, and initial, the constant is initial displacement, que es the position initial when you start the problem, no? Okay, I suppose que everything que I discussing so far, you know somehow in physics or in calculus. Okay, new idea. So you have 2 vector value function and you perform dot product. Okay, A and B now is no numerical vector. No, it's a vector value function. And you differentiate with the time, with respect to time. You apply the product rule. The product rule is derivative of the first vector dot product the second vector without derivative, and derivative of the second vector multiplication by dot product a vector. Okay, it's the same product rule that we discussing, but now we are working with the vector value functions. So A and B are vector value function. And si es cross product, exactly the same. No problema, no problema, no problema. A cross B is equal derivative A with respect to time, cross product B. Be careful with the cross product because you have to respect. Cross product is piggy, dot product is nice, dot product is community. We can interchange the cross product. No. Derivative B with respect to time, cross product A. Okay? Wow. Time fly. Time is over. Okay. Now, next day, Friday, I try to see the application of this. Guy, this is very hard, but it's very complicated. You see my face or no? You see my face or no? Let me stop